handling inequalities is 10 times harder than trying to solve an equation. So here we have this absolute value inequality, and I want to show you two methods. And one method will avoid solving this inequality directly, and the second method actually tries to do exactly that, solving it directly. So you should watch both videos. I'm going to make two videos for each method, and you should watch both of them and pick your favorite. Okay. Alright, the first method, you solve the equation. So what you do is, instead of thinking of this inequality, we just switch out this inequality and write this. Okay. Now this right now is completely different question than this on the top, but after solving this, it's going to help us to understand what happens here. Okay. All right. So let's see. -2. I'm going to subtract 3 both sides, and you get -8. Now divided by -2. And you get x minus 3 absolute value equals to +4, because negative divided by negative is positive. Now here, make sure whenever you have an absolute value equal to a number, that number is either positive or 0. If this is negative, then since absolute value can never be negative, you just stop here and say you write down no solution. However, here it's a positive number. In that case, what you do is you just write down x minus 3 equal to plus or minus 4. Then you want to think of this as two equations. One says x minus 3 can be +4. If you add 3 both sides, you get x equal to 7. Another one says x minus 3 could be -4. If you add 3 both sides, in this case, you get x equal to -1. But what we have is a solution of an equation, not the inequality that we are looking for. So how do you use this information to actually solve this inequality? Well, it goes like this. You put -1 here, you put 7 here, and think about like yourself being at a water treatment facility. In a gigantic water treatment facility, they have to test the waters to make sure that the water is treated correctly. When you test the waters, do you test all the water that is being cleaned by the water treatment facility? And the answer is no. What people do is they just take a sample, and if the sample turns out to be good, they trust that the entire water is good. And what we're about to do is exactly the same thing. We're thinking of this interval as three different this number line as 3 different intervals. There's one here before -1, there's another one between 1 through 7, and there's another one after 7. And what we want to do is we just want to choose one sample point from each interval. And I guess the smaller the number is easier, so I'm going to put 0 here. Choose 0. I choose 8. So these numbers, 0 and 8 and -2, if you use these numbers and you test it on this inequality, you can figure out whether the entire interval is a good one or a bad one. Okay, so let's start with x equals to -2. X equals to -2, if you plug that in, -2, absolute value -2, minus 3, absolute value, plus 3. Let's see, this is -5, but -5 absolute value is +5, and -2 times 5 is -10, plus 3, and that's equal to -7. Is this less than -5? Yes, this is correct. -7 is indeed less than -5, so that's a good one. However, you have x equal to 0. X equal to 0 would be -2, 0 minus 3 plus 3 equals 2. Then this is +3. 3 times -2 is -6 plus 3, that's -3. And that is not less than 5. This is bigger than 5. So that's no good. This is no good. So that's a no. X equal to, the next one is 8. We decide to choose 8. And in that case, again, 8 minus 3 gives you +5, so it's the same story as above. It's going to work again. So that's a good one. And that means here, let's just say this is -1. We'll divide this. Let's say this should be 0. 1, 2, 3, 4, 5, 6, 7. This is 7. We don't have to put all these numbers there. I'm just going to erase these. So here's 7, here's -1. And what we want is the interval. The interval that's correct is before -1 and after -1. Now, what I didn't mention is that if it's a strict inequality, then these boundary points, these endpoints, are not included as a part of the solution. If it had this equal sign right here, then you would put the closed circle. But here, right now, it's an open circle. Put an open circle here, open circle there. Now, how do you write this in interval notation? In interval notation, the first interval starts from -infinity, ends at -1, and these are parentheses. And there's another interval that starts from 7 and goes up till infinity. We use parentheses. These are open brackets, and we use open brackets when the boundaries are not included. If 7 was included, we would be using square brackets, but here we use open. And then finally, if you have more than one interval, what you do is you put a union to say that they're both solutions. So that's a solution. That's a solution graphically. And finally, I want to show you how to write this down as inequality. See, if x belongs here, what does that mean? X is left of -1, so you say x is left of -1. If x is here, then x is bigger than 7, so you say x is bigger than 7. Okay. So overall, you say this will be the answer for this. Okay. When you say -infinity, comma, -1, union 7, comma, 8, you're really saying that x is either in this interval or in that interval. So a better way to write this would be x is less than -1 or x is bigger than 7. So that would be a better way to write it. Okay. In fact, I think some teachers might take points off if you don't put the or correctly. Now, so here are the solutions. These are all answered. There are 3 different ways to write the answer of an inequality, and you have to know all of them.